Currently I'm working on projects seeking to improve nitrogen management in high rainfall cropping systems so that we can improve grain grower profitability and also minimise nitrogen losses, in particular nitrous oxide. So our work's been part of the National Agricultural Nitrous Oxide Research Program, which is funded through GRDC as well as the Federal Department of Agriculture. And our work's been focused in the high rainfall zone of southwest Victoria, where we're predominantly looking at different rates of nitrogen, different placements of nitrogen fertiliser, as well as looking at some of these nitrification inhibitors such as NTEC or dimethylpyrazole phosphate in terms of how they impact on crop productivity, but also how we can minimise losses of nitrogen, particularly nitrous oxide, into the atmosphere. So to date we're finding that particularly where we start supplying nitrogen fertiliser well in excess of crop demand, we are seeing larger losses of nitrous oxide. So one of the take-home messages is the importance of trying to match end supply to meet crop demand. Interestingly, we're finding that where we're placing nitrogen up front at sowing, that we're losing a lot more nitrogen into the atmosphere, and also we're seeing much lower crop nitrogen fertiliser recovery with some of our 15N work. And another key finding coming from our work is that we're seeing much better nitrogen recovery where we're supplying that nitrogen later on in the growing season at that first node. Our recoveries are up around 40% in the plant compared with around 10% where we're putting that nitrogen up front at sowing. We're also finding big differences where we're transitioning out of long-term pasture into cropping, particularly when we terminate our pastures 6 months prior to winter cropping, where we have a long fallow period leading into the winter crop. We're finding large build-ups of plant available nitrogen, particularly in the nitrate form, and we're tending to see a lot higher nitrous oxide losses compared with late terminations just prior to winter cropping. So we're finding that if we have long fallows in our environment, there's lots of potential for rapid, abrupt build-up of mineral nitrogen, particularly in the nitrate form. And once our soils become waterlogged and anaerobic, we're measuring alarmingly high losses of nitrous oxide. So one of the key take-home messages is trying to avoid long fallows in our environment.